Alright, so last week we were talking about speed. Now we're going to talk about something very, very closely related to it. You can think in terms of analogies. Distance is to displacement as speed is to velocity. So, quick review. You remember speed, we have our v equals s divided by t, or speed is equal to our distance divided by our time. That was scalar. Velocity looks really similar. Alright, so velocity is v with the little funny arrow line over it, which indicates that it's a vector. And then that is equal to the change in s, or displacement, divided by time. Alright, so that's why that analogy works. Distance and speed are both scalars. Displacement and velocity are both vectors. Okay, so that means that we're going to be working with displacement again. Alright, so, and since that's a vector, that's why velocity is a vector, because your direction, your displacement has that direction built in. So, and because you're using that to figure out your velocity, the velocity has to have some sort of direction. Alright, so SI units for velocity, it's the same thing as speed, except you have to, of course, remember your direction because it's a vector. So make sure you remember that part. Silly points to lose. So, average velocity. Just like speed, velocity has an average velocity as well as an instantaneous velocity. And it's the same sort of thing. We'll get into the instantaneous and what velocity looks like on a graph later. So we're just going to focus on average velocity right now. But similar to speed, where you take your total distance divided by your total time, average velocity is your total displacement, your change in s, over total time. Alright? So let's do an example. Average velocity problem. We have, typically, these are just to draw the difference between speed and velocity. We're going to do a little bit of both. Okay? So let's make that a little smaller. But we have Mr. Runner runs 30 meters north for 4 seconds. Then he stops and turns and runs east 40 meters in 6 seconds. Again, we're going to be using triangles again. So my suggestion for all of these problems is start by drawing a picture. Alright, so he's going to run north and then east. So let's draw, here is his north. Alright, and that's 30 meters. And then in order to add our vectors correctly, they need to be set up head to tail. So there's our, I think a little longer, 40 meters east. Alright, and then from there we can start kind of answering our questions. I'm also going to write in our times so that we know those. Let's see, the 30 meters north was 4 seconds, and this was 6 seconds. So, we did this last week. The average speed is easy. All you have to do is find your total distance. So, S is equal to, and notice I'm doing this in less I'm just not writing out the L and things like that. So, S is our total distance, which is going to be the 30 meters, plus the 40 meters, which is equal to 70 meters. And then we're going to have our total time, which is the 4 seconds plus the 6 seconds, which is 10 seconds. Alright, so there is listing our knowns. Our equation is speed is equal to distance divided by time. If we plug in, we're going to have speed equal to 70 meters over 10 seconds, which ends up being 7. And sometimes I will, it's okay if you write S and U in the same line. It's just the whole U is in there so that you don't forget this whole, you need meters per second. Alright. Now, finding the average velocity, we need to find our resultant velocity. So this is where you have to remember your Pythagoreans and your rules for adding vectors. So here is our velocity. Alright? So this part I will write out the lesson a little more clearly for you so that you can see how to apply it to a velocity problem. So we want to find our total displacement. No, and actually, this isn't velocity. Just kidding. That line that I drew, that is our change in S. Okay? So change in S is going to be Pythagorean theorem for 30 and 40. If you notice, this is another 3, 4, 5 triangle. It's just times 10. So if you did 3 squared plus 4 squared, you'd end up getting 25, and the square root of that is 5. 30 squared plus 40 squared is equal to 50 squared. Okay, so our change in S, if you don't believe me, actually write it out. So 30 squared plus 40 squared equals our change in S squared. Alright, so you'll have 900 plus 1600 equals 2500, and square root of 2500 equals 50. Alright, so that's going to be 50 meters. And what do we need to add on to that? So if you notice, this was north, this was east. Combined, it's northeast. Alright, total time, easy, same as before. 4 seconds plus 6 seconds. Alright, our equation is velocity, so don't forget the little arrow on top, is equal to displacement divided by time. So now we're going to plug in. We're going to have 50 meters northeast over 10 seconds. Our second S, that gives us 5. And then we just need to make sure we remember to add our units. Meters per second, and of course, remember our direction. Alright, so in the grayish brown color is average speed. In the green color is how you solve for average velocity. Alright, most of this is just applying what you already know to a new situation. Okay, so taking what you knew as far as distance and displacement and adding an extra equation in there. So now we're actually applying our displacement to our equation. Okay, so that's the end of the video. Make sure you do the online assignment and have some notes with you in class tomorrow.